Hello? Are we alive? Is everything alive? Has AI caught anything on fire yet? Hopefully not. How are you doing? You might be alive? Do you have proof? Do you have proof of this claim? Well, since we may or may not be alive, we should send out an announcement, yeah? At live notify, AI is making matrix transformations. Cool. How are you doing tonight, Slen? Anything interesting happening? AI is being kind of sleepy. This weekend has been a just like complete decompress and like do nothing type of weekend. It's been very nice. Nothing interesting, just dying while waiting for football season to start. Oh no, Glenn, if you die, I'm gonna send Russell after you. Okay? You don't want to know what happens when Russell gets a hold of you. He'll be like, "Heya!" He has a bowling ball, you know. You don't want to see what he can do with that thing. Um. Oh, and I should do one more. Let's not do one more. Um, maybe you do want to see what he can do with that thing? I mean, that's for you to take up with Russell. I don't have any control over this. But what I do have some control over is if we should react to something tonight. You think we should do a react? I have a short one. Let's do this a short one? It's like a 10. I need some short stuff in here. Everything I find that's interesting is too long. I mean, I don't wanna do a 20-minute video right now. Okay, we're gonna cheat. We're gonna skip video until end maybe. And then there's a non-zero probability that's gonna turn into skipping video. We'll see. Oh, I love that moment when the drawing cabinet decides it's going to disconnect itself. Will you reconnect yourself? I see that whole Haunts clip. You want me to react to Haunts? I'll give you my reaction to Haunts. Hold up. Hold up. Here you go, Len. Here's my reaction to Haunts. There you go. Does that count as our react content for the night? So, when we left off, Oh, I think I've done normalization and I've done dot product. So when we left off, we had most of the Quaternion implementation done. Um, Off stream, I went in and finished doing some unit tests. Everything is tested a little bit now, not necessarily thoroughly. And I fixed all the bugs that found, even though it's proceeding to yell at me about bugs. There are no bugs. See, we success. We pass all 178 of our tests. There are no bugs. But we never got around to implementing Euler angle and Quaternion conversion. So we're going to do Euler angle and Quaternion conversion. And then once that's done, we're going to start talking about matrix transformations. So that's the plan for tonight. So we're going to hop in up. How high up? Oops. Oh, there was a note I left in the code here somewhere that I was supposed to talk about. Oh yeah, in our implementation of two-axis angle from last stream, I wasn't properly undoing the division by 2. So I'm now properly undoing the division by 2 by doing a multiplication by 2 on the angle. Oh yeah. I feel like there was another one. Dream note? Oh yeah. I spent like an hour on this bit of code, like verifying it against online calculators and it not working. And then I realized I was an idiot and I was doing the order of things wrong. Instead of putting in, I was putting in WXYZ instead of XYZW like I was supposed to be. And AI was small CPU a little bit, but once I realized how to do my math right, all my math turned out to be correct. I don't want to talk about how long it took me to figure that out. Cool. So let's add in static basic Quaternion from Euler angle. So if an axis angle is, we have an axis to rotate around and an angle to rotate around, an Euler angle is instead that we have, an Euler angle is instead that we have a vector const vec radian 3. And so we have 3 values: rotation around the x, rotation around the y, and rotation around the z. We want to take those 3 values and we want to convert that into one quaternion. Well, it turns out that the from part is pretty easy because we just have a bunch of axis angles. So this is from axis angle, and our axis is x, so 1 on the x, 0 everywhere else. And then our angle is angles.x. We multiply that by 1 along the y and our angle along the y. And we multiply all that by 1 along the z and rotation along the z. And this should give us a quaternion that represents all the axis angles. To do, how optimized is this? Because the answer is probably it's not. Unless the compiler is really smart, and I don't trust it to be smart enough to make this a good calculation. But for right now, for the purposes of this stream, it's good enough. And we'll make it exist first, and then we'll come back and make it good later. The process of making it good will probably not be interesting. It'll just be copying a bunch of pre-existing code, which is exactly what we're about to do. So we're gonna do quaternion to Euler angles, which is, I hope, just copying down this code. But things are a tiny bit more interesting because they're talking that the formulas for the sequence body 321, and I think we might have 1, 2, 3 sequence. I'm not completely sure. So we're gonna have to test that this in fact gives us back what we originally had. So we're gonna have to do some calculation test on that. So I'll grab this over here so I can keep an eye on it. And we're gonna do vec radian 3 to Euler angles. And now we just do a bunch of copying. I think we're gonna try and use the simpler one for y. And hope it works, but we're gonna see. Now, this is going to be, in angles, do we have a tan 2? We do have a tan 2. Isn't that lovely? So, actually, what we're gonna do, we're gonna keep that math. Wait, that math. We're gonna keep that math pinned like here. Let's show a system title bar and we'll pin it. Cool. So we're gonna go auto radian x equals a than math. We want to use our version, a tan 2. And it's going to take 2 times w times x plus y times z. And then 1 minus 2 times x times x plus y times y. And now, I believe they said that there's a simpler version if we use arc sine instead of this tangent stuff. So we're going to try that. So we're going to go radian y equals stud math a sine. No, inverse sine. No. That a sine? Yeah. A sine, I believe. 2 times w times 2 times w times y minus x times y z. And then radian z is the math a tan 2 2 times w times z plus x times y, 1 minus 2 times y times y plus z times z. Cool. And then we should just be able to return x, y, z. And hopefully this will do both ways around for us. So let's go check if this checks out. So let's do another test case. And we're going to do Euler angles. Cool. And let's do stud math. I believe we just have quaternion. Quaternion from Euler angles. And let's do the stud math degree 45 0 0. So auto Q. And let's see if that compiles. Yes. Note the ABI has changed, but we're good. And let's take a quick look at what's popping out there. So we're getting Q. That looks like a 45-degree rotation along X to AI. And then let's do the inverse. So up here we had, yeah, A is a 45-degree rotation along Y. Let's check that. And then we're going to set Q equal to a 45-degree rotation. What did I do up here? We'll do a 45-degree rotation along X and Z, and that should give us the same answer as we got up here. No, that should give us the same answer as when we combine them together. Let's give that a check. And update our tests to check for the variables we're using. And hopefully nothing explodes. Yay, all the tests pass. So now we want to undo it. So we'll do Q dot 2 Euler angles. So auto E. And let's just see what that prints out for us. Actually, we're going to call that E radian. I want auto X, the math, the green X equals E radian dot X. We're going to do that for Y and Z as well. So the expected behavior here, they're going to get 45 degrees on X, 0 degrees on Y, and 45 degrees on Z approximately. I think there will be a little bit of loss. Uh-oh. Ambiguous overload or radian. Huh. Oh. Because we named the locals the same thing. I need to specify. Actually, let's name these out X. Outlying. Out Z. Then out X. Outlying. Out Z. That should fix this problem in a little bit cleaner way than I was thinking about doing it. And now, so we calculate the radian, and at a glance, that's mildly concerning. X, Y, Z. But we're not getting back 45, 45. What is it wrong? We're gonna leave a note here, and I'm gonna do some reading. Is this wrong? I don't know. My gut reaction is that it is, but it might not be. But figuring that out, I don't think will be particularly interesting. What will be more interesting is starting to get into some transformation matrices. We want to make some matrices that can do rotations for us. We want to make some matrices that can do translations for us. We want to make some matrices that can do scales. We want to be able to combine one of these 3x3 matrices with a translation. And I think I also want a function that takes like a translation, a rotation, and a scale and makes one matrix out of those 3 parameters. And then we have a couple of other useful functions here. So let's talk about what those represent real fast. As we do some, well, actually, nah. We'll talk about them if I get that far tonight. I'm not convinced I will. I'm expecting that tonight we're going to get these done. So let's do the rotation matrix. And there are 2 versions. There's a slightly easier to compute version that assumes that the matrix is a unit quaternion. And then there's a slightly less convenient version that assumes that it's not a unit quaternion. And my thought is, let's do both. We'll do a default function that assumes that it's not a unit quaternion. And we'll do another one that assumes that it is. We're gonna add matrix transformations.hpp. So we're gonna make sure that the compiler only includes this file once, and then we're going to include the matrix file, and we'll set up our namespace. So now we want some functions. We're gonna go template, type name T. Actually, we want another one, type name Q. And we're going to require that we derive from, I don't know. We're not going to constrain it yet. I'm going to say mat E33. So 3x3 rotation matrix. And this is going to call this TQ actually. And this is going to take a basic quaternion TQ. And we'll make that a reference to a quaternion. We'll call Q. So our goal here is to convert a quaternion into a 3x3 matrix. So we have the math for that here. So we'll pull that up, we'll pin that. And then we're going to do another version. Rotation matrix, non-unit quaternion. So we're going to do the easier to compute version, and then we're going to do the harder to compute version. We're going to return 1 minus 2 times q dot y times q dot y plus q dot z times q dot z, 2 times q dot x times q dot y minus q dot w times q dot z, and 2 times q dot w times q dot y plus q dot x times q dot z. And so this is the first row. And then we're gonna need a note here to do, are we column major or row major? Off the top of my head, I want us to work with HLSL, and I believe HLSL matrices are row major. They are column major. The new HLSL is column major. This that will be important for uploading purposes. We'll have to think about that. And let's get our math back. Oh no, stop resizing. Now we have 2 times q dot x times q dot y plus q dot w times q dot y. Oh boy. You guys like when there's a first-time chatter who just wants a Discord message? Can one of the mods who are floating around get that one out of there, por favor? Yeah, I would appreciate it. So 1 minus 2 times. I really love being part of this community as the first-time chatter. That one's pretty good. Is this based on DirectX? A good question since I'm entering HLSL here. No, but our target shader language. Quaternions are so 2025. You want your games to run optimally on next-gen hardware, you gotta use Quaternions? You're saying they got the 5D space version now, Nebu? Is that what you're telling me? Also, I call bullshit. More numbers means more computation. More computation means less optimized. Q dot x times Q dot x plus Q dot z times Q dot z. Nods. Nice. 2 times Q dot y times Q dot z plus Q dot w times Q dot x. 2 times Q dot x times Q dot z minus Q dot w times Q dot y. Is that why AI is so unoptimized and scuffy? Numbers too big? Probably. That probably has a big part of it. 2 times Q dot w times Q dot x. I have the biggest numbers. I'm going to assume that that's a compliment and say thank you. Q dot x times Q dot x plus q dot y times q dot y. Oh gosh! And now we get to do it again. Yang. So q dot w times q dot w plus q dot x times q dot x plus q dot minus q dot y times q dot y minus q dot z times q dot z 2 times are the corners. Corners are the same. So it's just the diagonal that's different, I think. And we're adding in bigger the full length, so we get some full length scaling. The q dot w times q dot w plus q dot x times q dot x minus q dot y times q dot y minus q dot z times q dot z q dot w times q dot w minus q dot x times q dot x plus q dot y times q dot y minus q dot z times q dot z q dot w times q dot w minus dot x squared minus dot y squared plus q dot z. Ay. Cool. And we're gonna add a long term to do. Convert notation matrix to quaternions. AI is not ready to do the math for that one at the moment. So now we got some slightly easier matrices. So if we go over to matrix transformations, that should be this one. And then we're going to do translation matrix. So we're going to do template type name T. And we're going to do mat T 4x4 translation matrix. And we're going to do this as a vector. Const vec E3 thing. So this, we want an identity matrix. We're going to do mat template. Do I have an identity matrix? I do have an identity matrix. Cool. So I'm going to do mat T4 for identity. So auto out equals. Then we're going to do out 30 equals e dot x. We're going to do out v1 equals v dot y, and then we're going to do out v2 equals v dot z. Cool. So this should give us a matrix that's all zeros, but a 1 running down the side. And then we have the translation and the translation slots. So out. This should be this should be AI being sleeping. This should be Use Zoom Fit Canvas. This should be 1, 0, 0, X, 0, 1, 0, Y, 0, 0, 1, 0, 0, 0, 0, 1. We should be getting that beautiful matrix out of this math. And if you go and check the video on homogeneous coordinates, you'll see that this defines a matrix that just slides a point around. So we've got translation. So let's do scale. Scale is easier. We're going to do template type name t mat E33. Scale matrix. And we're going to do the same thing. So we're going to call this position, and we're going to call this scale, and we're going to, and returning out might be helpful. We're going to do out is a 3 by 3 identity matrix, so one's all along. And then we can scale it. That's gonna, we'll do it the fast way. So out 0, 0 equals scale.x. Out 1, 1 equals scale.y. Out 2, 2 equals scale.z. And we can return out. That should give us scale matrix. And then we want two things. We want to combine. So we'll do template type name t, type name t quaternion, mat t 4 by 4. Actually, we're gonna need the other one first. So mat t 4 by 4, template type name t, make homogeneous. This will take a const mat t 3 by 3 as input reference. Make these go by reference too. 3 by 3. I can't call it that. Small. Then we're going to return small 0, 0. Actually, do I have that defined? I do. Nice. Small 0, 1. Small 0, 2, 0. Well, and then we're going to have the same set, but actually, we're going to have 4 of these. So we're going to go 1, 2, 3, and then down at the actually bottom, we're going to go 1. And we don't have these. It's all 0, 0, 0. Cool. Now that we can make our 3 by 3 matrices, I want the opposite. Let's do the opposite too. We'll do, actually, do I have something in here to pull out a submatrix? I do not. Do I want a more general submatrix tool? Probably. But for now, we're going to do template type name t mat t 3 by 3. strip homogeneous const mat T 4 by 4 reference big. We're going to turn a big matrix into a small matrix. It's going to look very similar. We're not going to have the extras. And then these are all bigs instead of being smalls. And now we want a transformation matrix. This is going to do two things. It's going to take a const vec t for position. Going to take a const basic quaternion tq rotation. And it's going to take a const vec t3 scale. And it's going to make a 4 by 4 transform. Do I want to support the 4? Let's just do the 3. And we're gonna do this the simple way. And we're going to do a translation matrix along the position. And then we're going to do actually. So the first thing we want to happen will be on the right. So we want the translation matrix to happen last. So position. And then we want, I think the scale and the rotation don't matter. We'll do the rotation matrix. Ting, ting. Giving rotation. And then we're going to multiply by a scale matrix given the scale. And we're going to return all that. It would be cool if I could make these const express so we could do this computation at compile time. We're going to add that as a to-do note sub issue. Make matrix transformations const expert. Would be nice if we could run the matrix transformations at compile. Cool. So let's go look at our, so we have the combined transformation. So the position, rotation, scale all together. And then we have the combining of 3 by 3. Should we have, let's do, should I, let's do another one. Template. Actually, after this, we'll do template type name team. Mat T 4 by 4. Line 3 by 3 with translation. We're gonna take a 3 by 3 matrix. All. We're going to take a position. And we're going to make the 3 by 3 matrix homogeneous. So small, auto out. Then we're going to go out 3, 0 equals position dot x. Out 3, 1 equals position dot y. Out 3, 2 equals position dot thing. Turn out. And then with that, for this one, instead, we can just combine rotation matrix, and then we can combine a 3 by 3, since that's what this will be with our position. And that should be a bit more efficient to do it that way. Um, cool. Where are we on time? We've been going for an hour. AI is eepy. But AI also wanted to get some work done. So we got some work done. Um, are you coding my own game engine? I am. Coding. Do you want the short answer or the long answer to that question? Can you guide me how to do that, please? Yes, watch the VODs watch all the VODs I have on my channel. My channel is literally designed to be the answer to your question. The long answer, yes, we're coding our own game engine, but at the moment, we're coding a math library for it. So yes and no. We are coding a part of our own game engine. But unfortunately, I think we might be close to calling it for the night. There anything else on the to-do list? I guess I could do lookout and perspective and orthographic matrices. I need to talk about MVP at some point. But that's probably not tonight. Well, my answer to that question is if you go to youtube.com/@Doxy_AI, there's a playlist here full of one-stream introductions to how to make a game engine. So we have how to learn C++. That's my starting recommendation. Then the math I recommend you know. And then a little bit about basic OpenGL. And then from there, once you know some of the basics of OpenGL, the question then becomes, do you want to make a 2D engine or a 3D engine? If you want to make a 2D engine, well, and what do you want to make? Do you want to make an engine? Do you want to make a game framework? I believe there's a I don't think it's out. There's a short that talks about the difference between a game framework and a game engine. But yeah, I guess the simple explanation was to go look at Raylib. Do we want something that just gives us like the ability to make windows, the ability to draw some simple stuff like key presses, draw some shapes, draw like a mesh, or do we want something like Godot that gives us? I have a picture of the editor. Or do we want something like the Godot editor? The Godot that gives us a full editor. If we're asking for like a full batteries included, does physics for you, gives you an editor, does navigation and AI and pathfinding, which is navigation, and material system, uh, game engine. That's a lot of work. You want to start by making a framework. You want to make something along the lines of Raylib, which just opens a window, handles input, handles sound, handles drawing stuff to the screen. And Unreal Engine is so unoptimized, and Unity is not for AAA title quality, and CryEngine has no courses or resources to learn. Well, so statement on that. I'd recommend just going and learning Unity or Godot. And so realistic statement, right? If you're here asking me how to start making a game engine, you're not going to be making a AAA game anytime soon. Sorry to bubble burst, but you don't have a team of 100 people who are all experts in various things. You don't got your 10 programmers, your 50 artists, your animators, your marketers, right? So your goal at the moment is not to make a AAA title game. So evaluating something on whether or not it can make a AAA title game is unnecessary for you at the moment. Your goal at the moment is to make something fun that people want to play. And that's going to be something small. Unless you want to so why do I say that? So let's say that you're going to make let's say that you want to make the next I don't know, Titanfall. We'll pick Titanfall. No, the next World of Warcraft. So we're going to say you want to make the next World of Warcraft. So some big AAA type game. How many features do you think that will be? How long do you project that will take you to do by yourself? A realistic answer to that is probably at least 10 years. So we're going to set down the idea that if we're going to make the next big AAA World of Warcraft, Tomb Raider, Call of Duty game, we're going to be devoting at least the next 10 years of our life to this idea. There is a 90% chance your game will not get any players and will fail. So do you want to devote the next 10 years of your life to something that most likely is going to fail? Or would you rather devote the next year of your life to something smaller that's still likely to fail, but will get you skills that will make you better? The idea, right, is you want each game to be a stepping stone that gets your skill set better. And as you get better and better, right, every successive game you release is less and less likely to fail. So do we want to spend 10 years working on one thing that is almost guaranteed going to fail? Or do we want to spend 10 years working on 10 things? And hopefully by the time the 10 years have rolled around, we've gained enough people who are interested in what we're doing, and that we might be able to put a small team together and then be able to make a larger AAA style game. Does that rationale make sense? So at the point where I imagine random viewer on my stream is, right, evaluating a game engine based on the fact that it can't make a AAA title game is basically irrelevant. wrestlers in. Can we get a ban on the viewer bot, please? Thank you. Um, so the question then becomes, what do I want to make? And then the follow-up question is, what skills do you currently have? If you've made a few games before, if you know a little bit, start making like a 3D platformer or something. If you know nothing, 20 games challenge. I've been a big advocate of the 20 games challenge since I found it a couple months ago. I think that this is the way to start getting into games. They give you a list of 10 games, and you pick one from the list, and then they build on top of themselves. The idea is you implement Pong, and that teaches you some basic things. And then based on what you've learned about Pong, you implement Breakout. And then based on what you learned from Breakout, you implement Space Invaders, and then Asteroids, and then Pac-Man, right? You start building up more and more complicated games until you get down to something that's like a game, right? You start getting something like Doom, but like the old version of Doom, where with like the 2D billboard sprites, or get something down to like Portal. So you make some sort of 3D game with an advanced feature. So what are the features that my engine's going to support? So I have an observation about state of the industry, right? You look at Unreal, Unity, CryEngine, right? What are they all optimized for? We want games that look as much like real life as possible, right? So they're all optimized around being beautiful, photorealistic rendered engines. Well, that's cool. But what about the other side? I have specialized my graphics education in a field called non-photorealistic rendering. The way I used to explain it is like using the tools that Pixar uses. Oh, my audio is breaking up. Let's make the buffer size bigger. Is the audio any better now? Does that help? Mic check, mic check. Nice. So I've focused in what's called non-photorealistic rendering. So using the techniques behind like a modern Pixar films, right? To make films that look like old Disney movies. Or like one of the really big examples is the Into the Spider-Verse series, where they used modern 3D animation to get a very comic book type look, right? So the problem with the industry, like with all the existing engines, is you can do non-photorealism, but you're doing it as a hack on top of photorealistic rendering. So what if there was a rendering engine that didn't force you to add a hack on top? So it was just designed around giving you the tools to do stylized non-photorealistic rendering. So that's what I'm working on. I'm working on a system that tries to lend itself towards being a stylized rendering engine, if that makes sense. Does that help? I hope I didn't burst your bubble there with too much realism. Well, are there any more questions? Does Quaternion drag in magic? It does not. Cool. I don't know, Zlen. Can you ask a question? What's your question, silly Totodile? If it's not a good question, right? Can we stab a Totodile? AI thinks it's time for some Toto stabbing. Okay, Zlen. What thing you want to know if I do or not? What thing are we talking about, silly Totodile? Good talk. I appreciate it. Okay. So going back to our to-do list. And I guess we can move matrix transformations down into the in progress list now. So that's cool. We moved something else into the big list of things that are currently being worked on. Hopefully. Oh, and make matrix transformation const expert. We'll put that into to do. Hopefully we can move Quaternions and matrix transformations out soon. Next stream, hopefully we'll get both of these done. Should we talk I don't know. AI is sleepy. AI is thinking that we're gonna call we got like the progress I wanted to get done today done. So I think I'm gonna call it for the night. And we're gonna go pass out. So thank you everybody for stopping by. AI appreciates it. Are there any questions before I disappear for the night? Well, I am not seeing. Well, I think we're gonna disappear. Thank you for watching.